Right, so let's try and connect to the Mongo database now that we've started it, and then type the Mongo command line to start up the client. So let's see. Yeah, I don't think I've started it yet, so I'll do sudo mongod. Right, so there it is. So it's started, and it's listening at 27:017, and I'll start in a separate tab. I'll run Mongo. So again, both of these are on my path, so I can run them from anywhere. So there it is. So running Mongo connects to the server. The server sees that it accepted a connection, and here you can expect many of the same commands that you would same if you're running it at MySQL, right? You can show the databases. Oh, DBs. And right now I have local and project, so I have no databases, right? And so there's some similar commands that you would expect. For instance, I can create a new database just by using use. And so we'll create a database for this class, and we'll call it the whiteboard, and this is Spring 19. If you say show DBs, notice that it still says that it's not there, right? Instead, when you say use, it won't show anything in the actual database until you start actually storing anything in there, right? So we haven't stored anything yet, so that's why it doesn't show it. And some of the commands, here it is. So show DBs. So for our purposes, for our demonstration of playing around with the database, we're going to be playing around with the following data model, right? So we have a user class that has a couple inheritance, the student and the faculty, which inherit from the user, and we also have a one-to-many relationship of enrollments between the students and section. So many students can be enrolled in many sections. One section can have many students enrolled in it. Then we have a couple of one-to-many relationships of one faculty having many courses, one course having many sections, one faculty being able to teach many sections, right? All right, so we'll visit each one of these and see how we can implement this data model using Mongo and later on Mongoose, right? All right, so let's play around with this. So here it is. We first created the database, the whiteboard, and all the commands that follow that will be in base of or in reference to the current database that is being selected, right? So any command that follows will be against our whiteboard database. All the commands follow the following syntax. There are DB. They all start with DB dot, very dot notation, using the dot notation. Then the collection that you want to modify or interact with. Collections are the equivalent of tables, right? And then the commands are what you would expect, all the various CRUD operations, right? The create, read, update, and delete. Those are the most common operations, and those are it. So insert, find, update, and remove. And then, as in parentheses, any arguments that the function might need, right? Any data that you might pass in, any filters, any matching parameters. Okay. So let's start off with inserting a couple of things in here. We'll start off with inserting into a user collection. We'll start by inserting Ada Lovelace. So I'm just going to copy that. So there it is. So I've pasted in there, and it says that it comes back saying that I inserted at least one record. Right? And if you now do a show databases, notice that indeed whiteboard with the D, without the D, is now showing there. Right. So now we do see the database listed. We also can use the command show collections, which is the equivalent of show tables, right? Which shows to me that there's one collection, right? And collection, that like the name suggests, is a set, it's a bag, it's a collection, right? Of multiple records. And now we don't use records to refer to each one of these records. Instead, we refer to them as documents. Right? So we don't say tables, we say collections. We don't say records, we say documents. Okay, but there again, they're the equivalent. Also, you'll notice that one of the steps that is missing from here is that I have not defined the structure of user. Right? Unlike a table, in a table, the way I create a table is that I use the create command, but part of the create command is that I establish the structure of the data. Right? I say that it has these fields, they are these data types, and they are related to other records, other tables. There was no such thing here. Right? There's no equivalent in Mongo. Right? Mongo is not considered. It's not a relational database. Right? It's unstructured. Right? It doesn't stop us from inserting documents in the same collection that are not necessarily follow the same structure, right? So, for instance, if I type here, if I do a db.user.insert, and if I misspell username, right, and I paste here po, and maybe I don't even provide all the other attributes, that's fine. It inserts it just the same. Right? There's no validation, right, that any of these objects follow any particular structure. Okay, so these are just documents, right? That we'll later see they can be filtered. I can find these documents later, following certain criteria. Not that you would actually do this, right? Where you would mix and match documents of different data types, of different names, and you won't follow any structure, right? That's a bad practice. But nevertheless, it won't be what the shift here is that what the focus is that it won't be anymore the database's responsibility for verifying the structure, right? The database responsibility will only be for storing and retrieving data as fast as possible, right? And it will be unencumbered. It will delegate these roles of validation, right? Referential integrity. All these will be instead delegated to the application level. The application will be responsible for enforcing all the structure, right? All these other rules, right? It won't be the database's responsibility, right? Instead, the database is going to focus on being able to deal with lots and lots of data, right? Maybe geographically dispersed in multiple nodes that are fault tolerant, right? That know about each other, and so it's trying to solve other problems, right? That are bigger than relational databases. Okay. Once you have these collections, you can then ask for the content of these collections. You can say db user find, and find is it's another command, just like insert allows you to create new data. Find allows you to retrieve the data. So in this case, retrieves all the records, documents that have been inserted into the collection. Notice that one of them has a username, first name, last name, and whatnot, whereas the other one has this username. Right. Now, if these documents are pretty big with lots of attributes and whatnot, it might be hard to read. So you can provide other commands that can be strung together to somehow transform the data into whatever you want. One of the transformations is to pretty print or display this in an easier to read, for human consumption, right? So that adds white spaces and whatnot. Other transformations are things such as sorting or limit, where you want to only see so many elements, so many from a large collection. Okay. Yes. Yeah, we'll see that in a minute. But yes, find takes as argument a matching object, and it'll use it to find all those objects that match that criteria. Yeah, you can use a key. You can use any field in there. Yeah, we'll see that in a minute. Right, so we've inserted an object, and these objects are full objects in the full sense. Right, they contain all sorts. They contain all sorts of attributes, right? All sorts of data types, and some of those attributes can be objects themselves. So you could have any nesting of objects within arrays, within objects, in combinations of all different data types. So these could be fairly complex objects, right? Which a little bit removes the original need for relational databases, right? In relational databases, the way you create hierarchies, right, is to spread out when you spread out all these fields across multiple tables, the way you create relationships and hierarchy is to have foreign keys and primary keys. But here, the hierarchy is part of the object itself, right? So you don't have to necessarily split the data that is already hierarchical. You don't need to split it into multiple tables. I mean, that's what you do in Java. In Java, when you have a class that contains other classes that contains other classes, typically that's the only way to represent that in a relational database is to split it into multiple tables, rather than reference each other with foreign keys and primary keys. Here, you don't have that problem because the object is stored natively with its original hierarchy. Okay, so it kind of eliminates a little bit of what we need, the original intention or the original need for foreign keys and primary keys, right? The original need for them, right? Nevertheless, we do still have the same kinds of concerns that we have in relational databases, such as inconsistency or redundancy. So whenever you have the data that is being copied and represented multiple times, right, you incur in the same kinds of risk that you incur in any database. Right? Whenever you find yourself storing the same information multiple times in multiple places, you make your database brittle and risk adverse at introducing inconsistency, right? Where data that should be the same, even if it's copied everywhere, it makes it harder to say that you synchronize all these pieces of information. So typically, you would avoid having to maintain multiple copies of things all over the place, right? So the same concerns of normalization, right? The same concerns of first, second, third normal form apply here as well. Regardless of whether there's relational or non-relational, right? The same kinds of concerns apply here as well. So here's one single document, and whereas here is a multiple documents stored in a particular collection, you can then now show all the collections. In this case, we only have one collection, and we can use find to retrieve these objects. In this case, we have two. We have here Ada and Poe. The other thing to point out here is that notice that there's a field there that we did not create. Right? That field was created by Mongo. Right? This is the primary key that it uses to uniquely identify this document within its collection. Right? So it's uniquely identified within this collection. Notice the name of the field is called _ID. Right? So underscore meaning this is a field that is being managed by the database. This is not a field that you should manage. It is being managed by the database. The database generated this. The database uses this to do indexing, right? To make sure it's able to very quickly identify these objects when they're being retrieved. So you don't have a responsibility on maintaining this ID. Right? You can consume it. You can use it, right? And notice also that it's of a particular data type, object ID. That's a data type. That's an internal data type of the Mongo infrastructure. When it gets converted into JSON, sent back to the application through a RESTful service, this gets converted into just a plain old string. Okay. Also, when we look at Mongoose, we'll see that Mongoose allows us to treat it as if it were a plain string. Right. It does the automatic conversion between string and object ID. Okay. All right, we saw already pretty if it's something that's fairly big. And we can also retrieve objects using the find, and we can retrieve a particular document if we know its ID. But when we do the find, notice we have to make sure we compare it against an object ID data type. Notice that the find method, right, is a function, and it can take as argument a JSON object. See that? It's a JSON object, opens and closes here, and the just like any other JSON object has a field and a value, a parameter and a value. Yes. In this case, this object is used as to pattern match and find all the documents that match the criteria that you put in your JSON object. If you don't provide any criteria like this one, right, when you don't provide any argument in the finder, it interprets that as you want all the documents, right? You're not filtering, you want all the documents, so it retrieves all the documents. But if you instead provide an argument, it will pattern match and see which ones match. Okay. So for instance, in this case, we have 2 documents. Let me add just one more, maybe. Let's add username. So we did Ada, Tim, password, also Tim, first name, Tim, and last name, Burnsley. So I've inserted those, and if we do a find pretty, we have at least 3 documents, right? One with one Ada, one is Tim, and this Poe fellow. So we can retrieve it by retrieve find, and then providing here an argument to pattern match. And if we want to find by ID, right, it has to be of type object ID, and then a string in there. So say I want Ada. Oops. Has to be inside the quotes. Notice that it just returns Ada, right? Or if I want Tim, then I would provide the ID for Tim. Just returns Tim. Make sense? All right. All right. So this also takes a second argument. Find takes a second argument. And that second argument tells me which fields do I want. Notice that by default, it allows me, it comes back with all the fields, right? It says, but instead you can filter out and say, well, I don't want all the fields, right? Maybe I only want the first name, right? So I can provide here first name, and then a truthy, meaning I want that. I want the first name. And this, notice that it returns the first name. Notice that it returns the first name and the ID, which I did not ask for the ID, right? But the ID by default is returned all the time, right? Unless I explicitly ask it for it not to be returned, right? I need to be explicit and say no, I do not want the ID. And for ID, I can say 0, and there it is. So only the first name comes back, right? All right. So basically, this is the equivalent of saying, select the name of the fields that you want from wherever table, where, and then the whatever you pattern match there. Okay. You can also do the finder. You can also do the find instead of using the ID. You can pattern match other fields. So you can say, well, I want to find not by ID, but I want to find by the username. I know the username is Tim, so it returns Tim, right? The record for Tim. Okay. And you can provide other attributes here, such as password. There might be some you can say username. This might be first name Tim and password Tim. It returns Tim, right? But if I have the wrong password, notice that it doesn't return any. Right? So this kind of is treated as an and, right? Meaning it has to match all of the fields. For all the records that match all the fields, it'll come back with those. Now in this case, it was returning just one object that matched the query. It could have been several documents that matched all the attributes that were passed in there as an argument. So there is a username Ada. In this case, we're asking only for the last name. All right, so let's start looking maybe at something a little more interesting. Let's look at section. So let's insert a couple of sections in here. So let's insert that section. Let's insert another one. Notice that there's a course there, presumably referencing the ID of some course, or maybe some unique identifier for a course, right? So this course here is kind of playing the same role as a foreign key, right? I could perhaps retrieve the course whose course name is CS102 or CS101, right? And then it'll retrieve that particular course, right? There's no such thing in Mongo as foreign keys and primary keys. Well, I'm sorry, there are primary keys, but not the same way where primary keys in relational databases. In relational databases, primary keys are unique keys, right, that happen to be used for enforcing referential integrity. Meaning, if you have a parent-child relationship between a primary key and a foreign key, you cannot remove the parent without removing the children, right? So that's referred to that enforcement of relational databases enforcing that rule is called referential integrity, right? Or that if you try to insert a child referencing a parent that doesn't exist, again, it won't let you insert that, right? Because you're inserting, you'll be creating an orphan, right? A record that doesn't reference any parent that actually exists. Again, all those rules are referred to as referential integrity. None of that is enforced here. Right? Again, all of that enforcement is relegated to the application layer. All right, so we inserted a couple of sections, and we can now start querying and saying, okay, well, now return to me all the sections that are in this particular course, right? So, for instance, there are two sections in that have that particular course. And there are two other sections that belong to CS102. So these are two completely different set of sections belonging to two different courses, right? This is almost like a join, right? Where you're saying, okay, so I'm grabbing information from sections that is somehow related to something else, right? These particular courses that don't actually exist, right? And that too, there's no such thing as a join in Mongo. There's no such thing as two records somehow related to one another and you joining them to identify which ones match, right? Again, the joining is a artificial concept in relational databases because of the fact that you broke up something that was hierarchical in something that is not hierarchical, right? But you want to reconstruct the hierarchy, right? Because you know that there's some information that ended up in that table and there's some information that ended up in that other table, right, that actually are together, right? They're supposed to be considered together, right? In Java or object-oriented technologies, the hierarchy is part of the language. That's how you build the classes. Classes containing classes and whatnot. Yes, one inside of another. Same thing in Java. In JavaScript, in JSON, you can have objects containing inside of other objects and containing other objects. There's no point there's no concept of this somehow living in separate collections and you having to bring them together. Nevertheless, Mongo allows you to do that if you want to split things into multiple collections, right? It's just that it doesn't facilitate any special treatment at allowing you to join these together somehow, right? We'll see later on that there's we'll use a library, Mongoose, the Mongoose library, which provides something that looks like a join, right? But it's not really, right? It's basically finding. I have this set of records in this table, which has values that are somehow related to some other collection. I would like all those other collections that are somehow related to these collections, and we'll do it at the application level. The application level will deal with that, as opposed to the database. A couple other things. Notice that the first query here, CS 101, returned two documents. These two sections with different seats, different names. So we can narrow down this to provide some other constraints. We're going to say, well, I only want the ones that has the seats, where the seats is equal to 12. Right, and now it just returns that one document as opposed to all the documents. Right? Yes. Yeah, we'll do an or and an and in a second. Yep. You can do all sorts of comparisons, right? Whether a particular value is within a particular range, right? I only want the sections whose the seats are greater than 30, right? And the way the syntax of all these commands, usually, again, they're still all JSON objects, right? That you pass in there, and for instance, for greater than, the syntax is that you first put the field name that you are comparing, then the operation, right, and then the value that is being compared against. So greater than. Notice that there's a $ in front of it instead of GT, and that means that this is a specific token that only the database understands. It's not a variable. It's not a literal, right? It's a token that the database understands as a command. In this case, greater than, right? So if I select that, it returns all the sections that have a seats greater than 30, regardless with which course. Course CS 102 or well, in this case, it's both for 102. Yes. Yes, yeah, you can override that and say that you want to generate them. And actually, for the assignment, you'll need to. There'll be numbers and the specific IDs, right? So that the TAs can run a script, and we'll validate whether everything works. So yeah, we'll have to be using specific IDs for this to work, not these randomly generated ones. You can also use a function. So use a function. The function will generate something, right, and that will then be unique. You can use also Boolean expressions such as and or. The syntax is, again, the outer is a JSON object, right? Starts with JSON, and which has the attribute name is either and or with a $ in front of it. Again, this is a token to be understood by the database, and the and operation takes as argument an array of objects, right? An array of objects where each object can be a separate predicate, right? Where these predicate could be, again, another and or, right? It could be some other complex combination of predicates, right? In this case, it's combining two greater thans. So it says, well, now I want all the sections that have a seat, greater than 30 but less than 40, right? And if we run that, right, it comes back with this particular section that has 34 seats. Okay, makes sense? You can also manipulate or transform the data that comes back from retrieval, right? So that initially this is the data that is being inserted is not sorted in any way, right? If you ask for it, it will be displayed in the order in which you inserted them, right? But that's only for convenience, right? You should never assume that the data is sorted in any particular way, right? But if you need to sort it, it will be only for display purposes, right? It won't resort it, right? The data stays the way it was inserted in the first place, with some indexing to improve its the retrieval process. But in this case, we are sorting it by the seats, so 12, 23, 34, 45, or we can sort it backwards in this descending order, right? 45, 34, 34, 23, and 12, right? Yes. Yeah, you can provide multiple fields to sort by. Yeah. Yeah, and a comma separated. You put it in comma separated. Yeah. So notice that the first find queries the collection, filtering it, saying what are the records that meet that criteria, and then you can pass in any number of modifiers. In this case, sort, limit. There's a whole bunch of modifiers that can transform your data into any particular output. There's a plethora of comparisons. We're not going to cover all of them. You can compare equal, greater than, or equal. In, right? If you have an array, you can put an array of multiple values and compare against any value in the array. Less than or equal, not in. You can have others, logical selectors such as and, not, nor, or. You can also do all sorts of aggregators like grouping, counting, skipping. I haven't had a good experience with limit and skip. When you have huge databases, where several terabytes, limit and skip don't work very well. Right? You can say skip the first million records and it'll just sit there forever. Actually going through the million records to find where that is. So they still have some improvements on performance, on being able to optimize some of these operations. A couple other things, we can update records that are already there. So for instance, we can find a particular section that has a particular name and just retrieve the seats, and maybe we want to update that, right? We can update it because somebody has registered and we need to update the seats, and decrement the number of seats. Right, so for instance, you can here we are updating. We're saying update name 02 and set the value of seats equal to 22. Now, notice that I have a careful in there. See that? Careful, because the way we would interpret that, right? Update, section, right? Section update. I want to update the section whose name is 02. That makes sense, right? I have to. This is the where clause. Okay, so I found the document, and then the second argument, seats : 22, that says, well, I want to update the seats equal to 22. If you do that, what you'll do is that you'll replace the document and say, okay, remove the old document, throw away the name, throw away the section, throw away all the other fields, and the only field that will survive is seats. Right, so you've lost all the other fields; they're gone. Right? Instead, what you probably mean is that you want to modify that particular field, only that field. Right, so instead of using the seats 22, probably what we mean is that we want to set. Right, we want to modify this field to be 22 because somebody just registered. Right. So if I do that, notice that it says that 1 was modified. And we can retrieve all the seats and notice that it went from 23 down to 22. Make sense? Okay. And finally, there's you can remove documents that are already there, and say, for instance, we're removing the section whose name is 02. It's gone, says that it's removed. If I try to run that again and say that it couldn't find that document anymore. And notice if I try to find it, again, it's not there, right? There's a whole plethora of other commands that we're not going to consider. There's insert one, insert many. Like you can provide an array of multiple documents that you want to insert all at once as a batch. You can update one, update many. replace one. There's delete one, delete many. So I encourage you to go take a look at some of that documentation. But we're not going to, for the most part, we're not going to be using them here in this class.